Hello everyone, welcome back to another video from sysadmin 102. In today's video, I will share with you my experience and recommendations on installing OPNSense on the ZimaBoard. So recently I decided to purchase a ZimaBoard for a completely different purpose. But since I have it, I decided to run OPNSense on it to see if it's good enough to run OPNSense. And the version that I purchased is ZimaBoard 232. Notice it's only dual core. Yes, it can handle the traffic based on my testing. However, you will experience a lot of bottleneck due to inadequate hardware. In addition to that, it's using the Realtek for the Ethernet. And as you know, it have a lot of issue with the free PSD. There is a workaround for it. I'll show you in this video as well. However, if you already have one, laying around, and you don't have that many devices at home, I would say 10 to 30 devices it should be working fine. The TBD is only 6 watts, would mean that this is super electric saving if that's something that you're interested in. And it comes with the 2 GBE. I'm hoping that the future they're gonna release the version with the 245 GBE. It's really affordable now, almost the same price like the GBE. So hopefully in a future release they're gonna upgrade it to 245. And all these CPU are supporting AES new instructions, which gonna help with the encryption. If you are looking to purchase a new one and use this as your OPNSense or PFSense, I'm not really recommended to. If you're serious about running OPNSense, I highly suggest that you go on with system that include the Intel network interface cards out of the box, such as like a small form factor PC or a dedicated firewall hardware. The reason being that Intel a lot more reliable compared to Realtek. The ZimaBoard, it come pre-installed with the Casa OS. So this is what the interface look like when you log into Casa OS. It's just a management system that you can, it have the app store of all based on Docker. So you can install all this Docker. However, I'm playing a little bit with it, and I can see there's a lot of security issue with this home cloud server, I would say, managing system. If you interested in this, please put it in the comment, and I can make a video discussing some of the issue that I see and possibly some mitigations that can help you harden your Casa OS if you decided to use it. Personally, I wouldn't use it. There's too many issues with it. All right, and that concluded the intro. Let's get started with step number 1, which is we're going to create a bootable USB. All the link that I use in the tutorial are going to be included in my written tutorial, which is down in the descriptions. So I'm going to go back to the written tutorial, and we're going to open the first link. That's going to take you to the download page. And right now they only have AMD 64, so that's the only options. And then since the ZimaBoard have the VGA options, we can leave that at the VGAs. Keep in mind that the ZimaBoard using the mini display, I believe. Yeah, mini display port, which you will need to buy an adapter from mini display to HDMI. It's pretty affordable on Amazon. And then for the locations, pick the one that's closest to you. It's gonna be faster. So here I'm in the West Coast, so I'm gonna select that one, and I can select download, and we're gonna save it. Next, we're gonna open terminal, and then we're gonna do a change directory to download, and then I can run the SHA sum .a 256 should be OPNSense dash 2447. And that's gonna generate a checksum for us, and you can compare with the one that lists on the website, and it match, which means that we have a good file. Next, we're gonna extract that zip file. All right, now we have it extracted. The next step is to create a bootable USB using Balena Etcher. All right, so I already have it downloaded. However, you don't have it downloaded, you can head over to my tutorial. There is a link for it that take you to download the Balena Etcher. Make sure that you inserted a USB. And then we're gonna select flash from the file, and we're gonna select the option image. And then we're gonna select a target. That's gonna be whatever the USB that you plug it in. I'm gonna select that one, and we're gonna select flash. Then it's gonna prompt you to enter your password. All right, now that the flash is completed, the next step is to plug in the USB to the ZimaBoard so we can install options from it. So some of the hardware requirement, you'll need a USB, obviously, and then a mini display port to HDMI or whichever input that your monitor support. And then you would need to plug in the keyboard as well. And let's get started. Immediately after plugging the power, make sure that you press the delete key until the BIOS menu will show up. And then we're gonna navigate to advanced and then select the CPU configurations. From here, just make sure that the core number 2 is enabled. When I receive the ZimaBoard, the core number 2 actually disabled, so make it a little bit slower. And then you would navigate to chipset and then select the second options. From here, we're gonna go down to the last option, SCC configurations. From here, we're gonna change, make sure that the speed is set at HS400. When I receive it was set at HS200. So just make sure that you select the maximum speed that it allows. That's gonna make the installation go a little bit quicker. And then we're gonna head over to the boot menu. Make sure that the boot option number 1 is your the USB drive that you plug it in, and we're gonna select that UEFI. And once you've done that, you're gonna select F10 and enter. That's gonna boot us into the option installations. You can press any key to manually assign an interface, or just let it automatically detect and assign the interface. All right, and now it's fully loaded. We're gonna log in as installer to start the installation. So login gonna be installer, and then the password gonna be option. So OPNSense. And you can just continue with the default key map, or you select whatever key map that apply to you. And then we're gonna select enter, and we're gonna select the default option, which is ZFS. Since we only have one storage on it, we're gonna select the first option, Stri, and you're gonna select space. That's gonna select the first one, and that's gonna format the partition 0 and 1. And we're gonna select enter, and we're gonna move over to yes and select enter again. All right, next you have the option to set the root password, or you can access and reboot, and then you can change this later on in the GUI. So we're gonna select complete install and access and reboot. All right, so now that it boot up, options already automatically detect the LAN and wide area network and assign the IP address. But however, should you need to assign a different network interface or switch between, you can log in using the default login, which is root, and then the password with OPNSense. And then from there, if you select option number 1, you can reassign the interface. And let's move over to the web GUI. I'm gonna show you the mitigation to have it become more stable with the Realtek Ethernet NIC. So after the system restart, we're gonna access the OPNSense portal using the default IP address 192.168.1.1, and we're gonna go to Advanced, and we're gonna select accept the risk and continue. And the default username is gonna be root, and password gonna be OPNSense. And from here, we're gonna follow the wizard to set up the initial. Hostname, I'm gonna change this to OPNSense-Zima. And then domain, you can just keep local domain, or if you have an actual domain, you can change it. Primary DNS server, I'm gonna use my local DNS, but feel free to choose the DNS of your choice. All right, and we're gonna enable DNSSEC support, harden DNS data. Next, then you're gonna select your time zone. And we're gonna keep everything as default. You have the option to change your LAN IP address, but for the testing, we're gonna keep it the same. And then you can change your root password from here. All right, and once you done that, we're gonna reload the changes. All right, and if your ISP not supporting IPv6, or your setup behind a firewall that disable IPv6, the first thing we're gonna do is we're gonna head over to interface, and then go to wide area network, and then we're gonna disable IPv6. My setup not supporting IPv6 at the moment. I'm tunneling my whole network to a VPN that does not support IPv6. They're gonna make it quicker for the when you go update the firmware, because typically when you do a firmware update, it's gonna query over IPv6 first. If you don't have a routable IPv6, it's gonna keep spinning like it's not responding. And then next, we're gonna go back to system, and we're gonna select firmware, and we're gonna select settings. So from the settings, we're gonna select the one that closest to your area. So for me, they're gonna be San Francisco. We're gonna save it. I'm gonna head back to status and check for update. So before we can install the Realtek plugin, that basically installing the Realtek vendor driver. They're gonna mitigate all the issue with the Realtek on the OPNSense. However, in order to do that, you have to first update it OPNSense to the latest versions. I'm gonna select update. Okay. After the system reboot, we're gonna log back in, and then we're gonna select system, and we're gonna select firmware, and we're gonna select plugins. All right, and we're gonna search for Realtek, and we're gonna install that one. All right, it's done. And next, we're gonna navigate to interface, and we're gonna select setting. By default, it the hardware CRC, TSO, and LRO. By the default, the hardware checksum uploading or CRC, and the hardware TCP segmentation uploading or TSO, and the hardware LRO or large receive uploading. It's disabled by default. However, if it's not, make sure that you check it. And when we done that, we're gonna restart one more time for it to take effect. All right, and we're gonna log back in after the system reboot. So in my experience, I find that the Realtek NIC, it behave differently. Possibly due to the NIC with the different firmware versions may behave differently, and the fix may be applied unevenly across the model. So you might need to experience with each NIC on your ZimaBoard. So for mine, that the RE1, I find that the RE1 is not as reliable compared to the RE0. So over testing, I have to switch the wide area network to the RE0, and I find it a lot more stable. With that being said, we're gonna do some quick testing. All right, in order for me to test the server, I will need to enable Edit Edge service. So we're gonna head over to System, and it should be under Setting and Administrations. And from here, we can enable a secure shell. So by the way, this is not the way that I normally do it. There is a tutorial on my channel as well as on my blog regarding the security hardening that I went over how you should set up your secure Edit Edge and how you should log in. But for the testing, I'm gonna permit root user login and permit password login. You can use these for like a quick administrations, but just remember to disable it if it's not in use. All right, and I'm gonna select set. Next, I will need to install the iBird 3. So we're gonna go back to System and then Firmware, and then we'll select plugins, and we're gonna search for iBird. We're gonna install that one. All right, and we're gonna go back to Lobby and Dashboard. So that's where that we can monitor the CPU usage as well. And then I'm gonna open up a terminal. And I'm gonna need the second one as well. So for the first one, I'm gonna log in the Edit Edge. So the command is gonna be Edit Edge, then the username, and add the IP address or the domain name for your options. So it's gonna be 192.168.1.1. And yes. All right. And we're gonna select option number 8 for shell. And on my MacBook, I'm gonna start iBird 3-S to start a server. And the first test we're gonna do to measure the TCP performance. So the command gonna be iBird 3 and -C for a client. That's gonna be the IP address of my MacBook where the server is 168.1.100. And then we're gonna specify the buffer size to a 64 KB. So -L and then 64K. So the number right here, 918. So that the total amount of data transferred during the test is 918 megabit. And then the achieved network bandwidth during the test is 770 megabit per second. So for the test that run during 10 seconds, the number of the package being retransmitted at 349 is kind of high. That's suggesting that congestion or issue with the network hardware, or the combination of both. In this case, at the Realtek NIC as well as the CPU, it underperforming. The next step, we're gonna run it to evaluate UDP. So the command gonna be iBird 3 and -C for client again 192.168.1.1, actually 100, and -U for UDP, and we're gonna specify the bandwidth being test at that level and 1 GOV, so 1 gigabit per second. You can see that we can only achieve 374 megabit per second. And right now I'm actually testing it on the RE1. Like I said, it doesn't perform well like the RE0. So we're going to switch over to RE0 and we're going to run the test again. All right, after switching RE0 and RE1, we're going to rerun the test again. We're going to rerun the 64 kilobit test. So compared to the first one, it actually, the bit rate is better, but the retransmitted is actually a little bit higher. But then you can see that from the both end, the transfer and the receiver is 1.05 gigabit, would mean that that doesn't have any loss. However, the 1275 package got retransmitted due to the CPU bottleneck. What you see when we run the test, I'm gonna run it one more time. Now look at the CPU UH. It almost like at 100% at all time. So we can assume that this is due to a CPU bottleneck. Part of it probably due to the Realtek driver issue as well. And we're gonna rerun the second test as well. It's still pretty inconsistent, but it's a lot better compared to when we run it on the RE1. And lastly, we're gonna run a 20 parallel stream to stress test the network. So the command gonna be ipert3-c 192.168.1.100 and then -p, and we're gonna send 20 stream. So from this test, you see that we have 952 megabit per second on the sender and 922 megabit per second on the receiver. So the total aggregated throughput across the 20 parallel stream at 952 megabit per second on the sender and 922 megabit per second on the receiver, which is close to 1 gigabit per second. This is suggests that it's handling the high load, but maybe nearing the saturations. Of course, it is because due to the CPU's bottleneck, as well as a little bit of a combination of both and the Realtek driver issue as well. And if you see the retransmission, it's the 93,626, which is as indicate the congestion or performance issue. Again, it's a combination of both the CPU and the Realtek Ethernet. So my final thought on this: if you already own a ZimaBoard, it's worth it to experiment with the OPNSense for light duty tasks or learning purposes. However, for the reductions or high performance setup, I would suggest that you're investing in hardware with better native support with the Intel NIC instead of using any hardware with the Realtek. It's just more trouble you have to deal with. Again, I highly suggest is going with system that include the Intel NIC out of the box, such as a small form factor PC or dedicated firewall hardware. And that concluded today's video. If you think that the video was helpful, don't forget to subscribe, like, and share. Thank you for watching, and I'll see you guys in the next video. Bye bye.